The title of this talk is Cognition, Affect, and Learning, subtitled The Role of Emotions in Learning. Now here on this planet, I go by the name of Barry Kort, having earned my education at the University of Nebraska and Stanford, but that's actually not quite true. My real name is Barsoom Tork, and I'm an anthropologist from Mars. And I came down to this planet about 70 some odd years ago to study the lifestyle of the creatures, the earthlings on this planet. I came down from the Martian Institute of Technology with funding from the Martian Science Foundation. And my supervisors said, "What are you finding down here on this planet?" And I said, "Well, there's these dominant creatures, some 8 billion of them. They call themselves Homo schleppians. And they have two very interesting features. Feature number one is that they have the ability to learn their entire life, which is interesting. First of all, they're made of meat. And second of all, they have this faculty of being able to learn." And they said, "Well, that's kind of interesting. What else about them, Barsoom?" And I said, "Well, they have this other property, which is quite remarkable. They have this characteristic that they call affective emotional states. And they have all kinds of emotions that you can observe among these creatures." And my supervisors on Mars says, "Is that a coincidence, or is there any underlying relationship between this ability to learn and this feature of having emotional states?" And I said, "Well, let's see if the MSF, the Martian Science Foundation, wants to fund me to study that." And sure enough, that's what happened. And so here's the results of that study. Now, when I used to give this talk back some 20 some years ago, I just had a set of PowerPoint slides. But after about 8 years, I decided to turn those PowerPoint slides into an encyclopedia article with the narrative interspersed with the slides. And so this becomes this encyclopedia article. And I first put it up on Google Knoll. Some of you may remember that Google came up with their answer to Wikipedia, which was an encyclopedia site that they called Knoll, K-N-O-L. And the main difference was on Wikipedia, I could not write an encyclopedia article on my own work. That's against the rules on Wikipedia. You cannot write an article that involves your own work. But on Google Knoll, you could. So I wrote around 2010 or so this article, and it was well received. The people who ran Google Knoll actually elevated it to one of the top 5 encyclopedia articles. And after Google Knoll ceased operation, they ported it over to WordPress, and then from there I ported it over to Google Sites. So this is something like a 10-year-old version of this encyclopedia article. Now, normally when I give this talk, I like to introduce it with a bit of an anecdote. And so I wrote a little allegory. It's called A Conversation in the Garden, and I'm going to walk through that, partly because maybe not everybody's here yet, and this will buy a little bit of a time. And you can see I wrote this 2008. So this is about a little girl who goes for a walk in the garden, and while she walks in the garden, she likes to talk to God. So one day, the little girl's walking in the garden. She's talking to God. She says, "God, can I ask you a question?" God says, "Sure, I love your questions." Little girl says, "God, when you made me, how come you didn't just give me all the knowledge like the adults already have?" God smiles. He says, "Oh, my child, I gave you something far more valuable than the knowledge the adults already have." The girl says, "You did? What's that?" God says, "My child, I gave you the ability to learn anything at all, including the things the adults haven't figured out yet." The little girl brightens and says, "Oh, that's neat." She walks on a little ways. After a minute, she says, "God, I have another question." God says, "I'm listening." The little girl says, "God, when you made me, how come you gave me emotions?" God says, "Oh, that's the best question anybody's asked me in a long time." The little girl wrinkles her brow and says, "You're keeping me in suspense. Tell me, God, when you made me, how come you gave me emotions?" God says, "Think about it, my child. Without emotions, how would you know what it was you needed to learn or be able to tell when you finally learned it?" Little girl says, oh, maybe this learning business could be fun. God smiles. A minute later, girl says, God, can I ask you another question? God nods his head, yes. Little girl inquires, can we meet again tomorrow? I got a smile out of Peter. Now, this encyclopedia article is actually pretty long. It may turn out to be too long for one session, but I at least want to do at least the first major part of it. There's a table of contents here. We're going to talk about basic concepts and terms, and the key thing is the role of emotions in learning. And we're going to do that by making an analogy, which I'll walk through, borrowing some mathematical concepts that people would be familiar with if they've studied the calculus, or even if you just have an intuition about motion. And then if we have time, I'm going to go into an application, which I call the Bardic Arts, which talks about how we make stories and how that ties into this. And there's a little bit more stuff that if we have time, we'll go into. When I first wrote this for Google's Knoll, the encyclopedia project, they introduced the word knoll as a kind of a chunk of knowledge, kind of like the encyclopedia level of a chunk of knowledge. And I sort of think of knowledge as a gigantic jigsaw puzzle that's assembled out of lots of little bits and pieces. And the pieces of information are woven into a fabric of knowledge. And then once you have the assembled jigsaw puzzle, all that raw data, that raw information yields a big picture. And that typically the big picture is hidden from view until you have all the pieces assembled properly, and then you get what I call insight, seeing the big picture. So we have this dynamic process, we call it learning, that takes place as we build a general knowledge base, and the rate of learning is generally not steady. We can learn in fits and starts. Sometimes we have to unlearn a misconception or two. So we have a learning curve that does not gracefully ascend, but has wiggles. And that's the thing we're going to look at, is what are the wiggles in the learning curve? Now, people can realize that there's lots of identifiable emotions that appear along a learning curve, along a learning journey. And so, for example, curiosity, fascination, confusion, anxiety, surprise, perplexity, frustration, chagrin, despair, hope, satisfaction, and elation. We want to kind of unpack this hodgepodge of emotions, see if we can put some structure into this connection between the emotions that arise in the course of learning and the learning process itself. So we're going to craft
Barry,
a model. Yes.
Barry?
Yes.
How did you know my morning with all those adjectives? That's what I feel like in the morning.
Well, because I've been observing the kinds of emotions that people manage to successfully display while they're sort of struggling their way through life. So, and you'll see that, and that's quite all right. You'll see that this initial subset of emotions is pretty recognizable, but there's lots of others that and we're going to enlarge the set of vocabulary terms and put them in a little bit of an order. So we're going to craft a model, a synthetic systems theoretic model of the interplay of emotions and learning, and then we're going to extend the model to encompass drama theory as well. Hopefully we'll have time to do all that. So here are elements of the model. We're going to consider knowledge as model building mental models or scientific models or hypotheses or maybe some kind of a narrative stories that we use. And so we construct our knowledge as a set of constituent parts, which I, as a scientist, like to think of as model building. And learning involves constructing knowledge, but also there's going to be unlearning. Again, because sometimes we have material in our knowledge that's just bogus, just baloney, and eventually we have to discard any misconceptions. So ascending and descending the learning curve is going to be constructive learning and unlearning. And then we're going to dive into the meat of the story, which is the role of emotions in this learning process. The most complex part of the analysis is something that comes out of calculus called a phase plane diagram. And this is the part that might be least familiar to people, but it also has the greatest meat to it. And then after that, if we have enough time today, we'll go into storycraft and the Bardic Arts, which involves an 8-layer character model of an arbitrary storybook character. And that leads to a theorem, which is kind of like theorems in game theory, except it's in drama theory. And I named it after Tom Clancy, and you'll see why. And then if we have time, a little bit more on interlinked economies. So one of the ways that we recognize emotions, you can just see them on people's faces. So here's a couple of pickle face characters. This is actually a Christmas tree ornament that's popular in Europe. And here's a very pickle face character who was in the throes of a bit of a scandal with her husband back in the 90s. And part of it is that emotions are visible, but they're not always visible. Sometimes the emotions are kind of hidden on the inside. But whether they're visible or not, they're relevant. So let's talk about some basic concepts and terms. More generally, I use the term affect as opposed to emotions. They're really synonyms, but affect is a little bit more of a clinical term. So when I say affective emotional states, sometimes we'll talk about affect, sometimes we'll talk about human emotions and feelings. So here are some examples of emotional axes that you can recognize as arise in the course of learning. And you can have negative valence emotions, unpleasant emotions, and positive valence emotions. And I, over a period of time, came up with 7 axes. And this just gives you an idea, for example, Harry, of some of the vocabulary terms that people will be familiar with. For example, if you have to present something and you haven't really done your homework, you might have some anxiety about it. And that's pretty common. And you don't want to be in anxiety. That's negative valence emotions. You want to be over here in confidence. And so if you hunker down and do your homework and learn your material, you'll migrate from these negative valence, anxiety, worry, discomfort into comfort, hope, and confidence when you've mastered your material and you can get up there and you know you're not going to fall flat on your face. There's also this boredom fascination axis which arises. So if I start to get long-winded and people get bored and their eyes glaze over, I've lost my audience and I want to maintain a level of interest, curiosity, and fascination. And this is true for the individual learner as well as the audience. There's this frustration euphoria axis. If you're trying to solve a problem, a puzzle, and you're not getting anywhere, you might feel frustration or confusion or some kind of general puzzlement. But when you have a breakthrough, when the light bulb goes on and you begin to see how to solve it, then you're going to get a sense of euphoria. You might get some endorphin rush for successfully figuring something out. So there's a spirit axis. One can be dispirited, disillusioned, dissatisfied, or on the positive side, wistful, hopeful, encouraged. So again, kind of a spirit axis. Then there's this fear axis, terror, dread, apprehension. On the negative side, calm, enchanted, enthralled, and awed. And again, the idea is that you want to migrate to the right on these kinds of axes, because then things are going to be a lot more fun, a lot more pleasurable, a lot more successful. Here's one that's kind of important, especially if you're learning in public. Humiliation, embarrassment, chagrin, if you're making mistakes and you're kind of losing your stature. And so you rather be on the side of being pleased and prideful. So sometimes this is a relevant emotional axis to pay attention to if there's public learning going on. And the last one that I added quite recently is this contempt, disdain, dismissive attitude towards the subject versus to appreciate it, to admire it, and to be inspired. So you have aversive emotions, kind of a neutral and appetitive, attractive emotions. And we want to learn about how all of this interplays with the learning process.
Hey,
Now,
Barry, was
yes.
there a reason you didn't have any neutral adjectives in there?
Well, the ones in the middle, I didn't put them in blue, but sort of in the middle, you might be able to come up with vocabulary terms that sort of neither positive nor negative. And in fact, that's the sort of the next thing I say, that modeling axes like these and finding vocabulary terms is kind of an open. I mean, if you're a poet or a writer of stories or whatever, or a psychologist, you might really try to find dozens or even hundreds of vocabulary terms and phrases and metaphors to represent variations along extreme negative valence and extreme positive valence. And a lot of times we are in the kind of the middle where there's really nothing to be said about it, just sort of in a state of calmness and neither excited nor disturbed. So it's far from a settled question, but we want to at least identify emotional axes and states that seem most relevant to the learning process, both for voluntary learning, that's what I would call the intrepid learner, the autodidactic learner, and for the involuntary learner, the reluctant learner who is obliged to attend a course or workshop where they're really not all that keen on it. And there's plenty of evidence that we experience at least some emotions while engaged in learning, but our goal is to construct a coherent model, a synthetic model of this interplay. So in the title of the talk, I use cognition, using one's noodle to think about and solve life's large and little problems. That's a learned behavior. We learn to think. I mean, you know, a baby doesn't have a whole lot of cognitive skills. And as we go through our educational career and our adult life, we gain tools for thought, and some of them can be very sophisticated. We learn from we learn from academic sources, from firsthand practical personal experience, from cautionary tales, stories, and dramas, and sometimes from our disheartening, embarrassing, lamentable, and crushing failures. You can learn from all sorts of mechanisms. Now, as you saw, I had divided the emotional axes in two halves of positive valence, pleasurable, negative valence, unpleasurable. Most activities will activate emotions on both sides. And so you can be in a state that they call neurosis, where part of you is sort of dreading it and part of you is sort of engaged, and you can actually have a tug of war between some positive valence emotional axes and some negative valence ones. That's kind of interesting because neurosis is not an uncommon experience when we have mixed feelings about something. But we want to go beyond these poetic metaphors to a comprehensive scientific model. And that's where we're headed. So let's fasten our seatbelts and get going. Now, everybody has probably heard of a learning curve. And normally when people draw learning curves, they draw a very nice, gentle, ascending learning curve where it tends to be steep at the beginning and gradually level off. That would be called a monotonic, always ascending learning curve. And I want to point out that that's not realistic. When we learn, we do not learn error-free. We're going to certainly have gaps, missing pieces, but we also can get misconceptions, pieces of baloney that get mixed in with the good stuff. And from time to time, you identify a hypothesis, a belief, a notion, a concept that's bogus, and you have to discard it and not rely on it anymore. So you can have an ascending part of the learning curve, then identify something that doesn't belong and discard it. And so that's called unlearning. And then now you have a gap where you had maybe a misconception before, a false belief, and now you try to build a better model and you have an ascending phase again. But this isn't a one-time only thing. You can still have gaps and misconceptions. If you have a new misconception, it goes away. So learning curve really has these wiggles in it. And this is the key notion, that instead of having a nice ascending learning curve that levels off, let's put the wiggles in and ask ourselves, what's encoded in these wiggles? And there's a big clue here. Notice that you have a phase where it's concave, that is turning down. You have phases where it's convex, turning up. And in mathematics, you would call this the curvature, would be called the second derivative in calculus. So we're going to talk about the slope, which is learning, the second derivative and higher order derivatives, which is the curvature, concave and convex, and sort of interpret those as where our emotions come from. And that's the roller coaster learning curve. So notice that I put a frowny face skull and a happy face smile on these concave and convex. So that's already your clue to why we're going to interpret those as representing the emotional states. The point here is that by drawing a learning curve as non-monotonic with these wiggles in it, you can see that there ought to be some mathematics that we can overlay on this to give it some mathematical structure. So we're going to have these sections where the curvature is concave, downward turning, convex, upward turning. And then the calculus, as I mentioned, we represent these as the second derivative. So again, the vertical axis on that curve was concepts, mental models, theories, beliefs, hypotheses, etc. And we want to reckon how our knowledge base of beliefs evolve and become increasingly refined, sophisticated, accurate, and insightful. So again, misconceptions, this is the key thing, gaps and misconceptions. This is what's going to make it wiggly. Now, sometimes the hills and valleys are so gentle rolling slopes, they have hardly any curvature to them. And if they have hardly any curvature, you might not have any strong feelings. But where you have very strong curvature, like eureka moments where they suddenly turn upward, or disastrous failings where they turn downward, the motions can be actually quite dramatic. So to summarize those 7 axes, just by labeling them by their extremes, we have the anxiety confidence axis, the boredom fascination axis, the frustration euphoria axis, the dispirited encouraged axis, the terror enchantment axis, humiliation, pride, and contempt and fire. Those are my 7 most obvious axes, and one can imagine maybe in devising more axes and more details, but this is a good place to start. So now we're going to analogize these ups and downs of the roller coaster learning curve to properties of a generic mathematical function that exhibits similar roller coaster behavior. So let's go back and remind ourselves of ordinary calculus as Newton introduced it. Newton started with ordinary motion, simply things in motion. So you have time, distance, velocity, acceleration of some trajectory of a moving object. This is the basic beginnings of Newtonian calculus, where you're talking about some kind of a journey, some kind of a motion. And sometimes I will use a little public puppet figure just to demonstrate something in motion, speeding up, slowing down, changing direction, just to remind people who don't really have a depth in the calculus is what we're talking about is just the elements of ordinary motion. Now, for people who get really deep into calculus, you might eventually, maybe in the 3rd semester, get to something called a phase plane diagram. And that's really where we're headed, where you plot velocity against acceleration. And we'll get into that a little bit later, because that's the heavy duty part of the math. You can also add distance as the 3rd axis. So you have a 3-dimensional phase space diagram. This is often used in rocket science. And this is really where you get some very strong math tools for thought. For example, in engineering, you may have done phase plane diagrams or phase space diagrams. So that part will be familiar. For a lot of people, I think that will be maybe unfamiliar. But we're going to do an analogy. The analogy is we're going to take time, distance, velocity, and acceleration, which is well known for motion. We're going to analogize those to the learning process: time, knowledge, learning, and emotions. Now I'm going to skip this one for a minute and go down here to this analogy so I can just lay it out a little better. So in ordinary motion in the calculus, you have time, distance, velocity, acceleration. Newton actually named the next time derivative after acceleration called jerk. And if you're driving your car and you suddenly hit the brakes real hard, you jerk. And that's a real sudden change in acceleration. And the guys at MIT actually invented a name for the next derivative, which they call jounce, which stands for jump and bounce. So you can think of a springbok, not going splat, but rebounding. So these, you actually have names for the 2nd, 3rd, 4th derivative. So here's our analogy that I'm going to unpack. Time is still time. Gaining ground is gaining knowledge. We're gaining ground in the knowledge space. The rate at which we gain ground, we just simply call learning. So I'm simply equating learning to the rate of gaining ground. And here's the breakthrough. What you would call acceleration in ordinary motion, I'm going to point out that this is how we experience emotions. What Newton called jerk, sudden abruptness, we experience that as shock. And jounce turns out to be resilience. So this is the kind of analogy that I want to unpack here with some mathematics. So let's go back up to this diagram. If you do a phase plane diagram in calculus, you would put acceleration on the horizontal axis, and you would put velocity on the vertical axis. That would be the phase plane representation of velocity and acceleration. And when you do that in a phase plane, you get 4 quadrants. In quadrant 1, imagine you're in your car, you put your foot on the gas, so you're accelerating. Positive. And when you look at the speedometer, it's increasing, you're gaining speed. So in quadrant 1, you're accelerating forward and you're gaining speed. Now, eventually you come to a coasting top speed and you're back here, you're neither accelerating nor decelerating, and you have simply a forward motion. If you put your foot on the brake or you fire your retro rockets, you're going to decelerate and your speed's going to come back down again. So quadrant 2 is deceleration of forward motion. Once you come to rest, if you continue to fire your retro rockets, you start going backwards. So now you're accelerating backwards. That's quadrant 3 of a phase space diagram. And then if you put your foot back on the gas, you slow down your backwards motion and you start to go back to rest and then positive and then forward motion. So in ordinary motion, this is the classical phase space diagram of acceleration versus speed. Now I want to introduce my analogy. I'm just going to plug in these two words for those two words, and we have the same phase space diagram. Positive affect, you're constructing knowledge bit by bit. So quadrant 1 is you're driven by curiosity to investigate something and build mental models, and you're building a set of mental models, and then you want to see, are they any good? Do they predict what's going to happen? Do they jibe with observation and experience? Now, if they do, all well and good, you keep on going. But if you have an expectation based on your mental model and it doesn't jibe with observation reality, you go, oops, something is amiss. And you end up over here in some confusion or surprise or disappointment where there's a disconnect between your mental model and observed reality. And so you have to diagnose, is there a gap? Is there a misconception? Is there something incorrect in my mental model? If there's something incorrect, you've got to discard it, and that's unlearning. So that's phase 3. This is what we call the dark tea time of the soul. This is where you have to discard your cherished belief that simply isn't jiving with observed reality. So you may experience at this phase not only confusion and surprise and disappointment, maybe frustration. Why is this thing that I'm expecting not working? And you can actually go into a state of dispiritedness, maybe hopelessness, because you're discarding these long cherished misconceptions. Now, once you grieve your loss, and there is a kind of a grieving process, then you move over here into quadrant 4, where you have to do fresh research to correct the mistakes. And so you get into hopefulness and determination. Roll up your sleeves, you say, all right, I'm gonna do it right this time. And if you have a breakthrough, an aha moment, a eureka moment, you get back up here with a better model. And you can go around this phase space in this counterclockwise cycle many, many times. Now, if it's not a misconception, if it's only a gap, you can go this way. Have a gap, go back and fill in the gap. But if it's a misconception, you've got to go down to the unlearning. So you're always cycling around this phase space in this counterclockwise cycle, and that comes right out of the phase plane diagram of the calculus. For those of you who ever want to go back and read this, I've got this whole narrative that I just recited written down here about these 4 phases. But you can see if I go back up to the learning curve, you have the ascending phase, you have the concave and convex phases of the second derivative, negative and positive. So all I've done is I've taken that diagram and simply redrawn it in this phase space. This is a very powerful way, because now if you're a learner or if you're working with a student or a child or a group, what phase are they in? Are they building their mental models? Are they playing and sort of figuring things out, leave them alone? Have they got a gap or a misconception? They're starting to get confused or disappointed or mixed up. Then you might want to begin to intervene. You might want to help them diagnose the gap and the misconception so they don't get stuck for a long time in frustration. And then when they identify, or as a coach or a mentor or tutor, you help them identify the misconception, you may have to give them a little emotional support. It's okay, this is not uncommon. People do, even the best scientists make mistakes. So there's kind of a coaching process here. And then when they're in quadrant 4, make sure they have the resources, the time and the energy. Are the students well fed? Do they have everything they need? So you want to sort of facilitate this process of going around and around, whether it's your own learning autodidactically or you're working with somebody else. I think before I go on to the next one, I think I'll pause to see if people have comments or questions or part here.
Well, I have a comment. is that in product development, you use all four quadrants.
Absolutely.
Especially, you design the product, but the producibility, the testability, the reliability, all that stuff. And then sometimes you get a piece in there that just doesn't work, and you find out what caused that piece not work. Oh yeah, that in engineering we've had that all the time, especially in proposals.
Yeah, exactly.
David, I think that this is actually a very universal diagram, and that if anybody who's done any project management knows you go around and around and around this circle all the time, dealing with all the if it's a big project, you go around and around and around, and the trick is to be able to recover out of phase 2 and not get stopped by that, and to move your way through phase 3 quickly, and get into phase 4 and to recognize it. I've been doing project management, and I never saw it like this, but I'm very aware of this circle you go through. And
absolutely. I agree with 100%.
Getting yourself through that circle and recognizing where you are, and that it's not all hopeless usually, and that you can just get yourself through that circle and you'll be okay.
Having been observing AI from one degree away, as in when I was at MIT, they were on the 9th floor, I was on the 5th. And when I was at BBN, they were at one end of the building and I was at the other end. I've always followed this model of intelligence, or in the speech understanding and text understanding world, that sort of semantic modeling as the key to it. And it seems like recently we've been hit on the head with this machine learning stuff. And it's a pleasure actually to go back and remember that there are a lot of people who spent most of the end of the millennium in this world, as opposed to what seems to be gathering all the attention these days. Do you have any comment on the relationship between the two models?
I do. In fact, one of the things that comes out of this is that this kind of learning curve is not restricted to humans. Anything that learns, whether it's a human, an animal, an alien life form, a learning machine, anything that has the faculty of acquiring knowledge incrementally over time is probably going to have a non-monotonic learning curve. Because why should a machine be any better at forming an hypothesis that's correct the first time out? Linus Pauling said, when you're trying to figure things out, you need lots and lots of ideas. He says about 19 out of your 20 ideas fall flat on the face, and you need to be willing to throw away the ideas that don't work. And he estimates that 1 out of 20 is the successful one that survives. And that's true whether we're talking about human learning, organizational learning, machine learning, alien life form learning. This kind of mathematical model is applicable to any learning being, any learning system, living, non-living, earthbound, not earthbound, Martian, you have it.
But do you think machine learning has phase 3?
Yes, because at some point, let's say you form a hypothesis in machine learning and you're testing it. So you have to do some kind of experiment to see if your predictions agree with observation. If they don't, you have to diagnose where is the model deviating from observation and what part of the model, if any, needs to be discarded. And so that discard phase, this is the discard phase, the unlearning. And so you're going to be in quadrant 3. Now, if you ask the AI, what's the shape of your learning curve in phase 3, they'll say, well, it's descending and it's concave down up to that inflection point. So the AI might not say, well, I'm feeling dispirited, but that would be the human metaphor. Metaphor, I'm really disappointed. I wasted all that time, building this idea and it's baloney. I expended all time and energy and resources, and I got no place except I found one more thing that doesn't work. We call that, unhappy. You can make clinical terms for an AI, but metaphorically, it's the same thing because you're just talking about the shape of the learning curve that is concave down.
Right, right. I've been to lectures where, in fact, the three guys who won the Turing Award were at Harvard once, and I went there, and a lot of people were asking, well, can you explain how it works? And these guys who were the experts in it and got the award for it really were incapable of explaining to a mere, a lay audience, if you will, even though there are a lot of Harvard guys there, as to how do we relate this back to our daily experience?
Exactly.
And I think a real service to the current world would be to show these cross links between what is classical AI will figure out what knowledge is all about, which is somebody like this approach, and the sort of magic that is being used very successfully these days, and that's the challenge, is to overcome current successes with understandable reasons why things are done the way they are.
Yeah, you can find perfectly good vocabulary terms for AI. So, for example, I don't know if it's on here. Do I have satisfaction and dissatisfaction? I don't think I have it on here.
Yeah, right there, right.
Yeah, there it is. Okay. So, for example, if you have a model and you're going to test it and it doesn't work, the AI say, well, I was dissatisfied with that model. And you have one that does work, you say you're satisfied. So satisfaction, dissatisfaction is about as neutral an affective term as you can use that applies to both humans and machines. The rest of these, you might say, well, they're really more, you would use these with humans, you wouldn't necessarily use them with machines, but it's just a matter of picking terms that perfectly validly express the affective state of the system, whether you want to call it human-like or synthetic. I mean, for example, I'm dismissing this theory because it doesn't work. Okay, I'm elevating the represented value. I'm appreciating a theory because it seems to be working. So I increase my confidence in it. You have confidence levels. So yes,
I don't know. I think you're imputing affect to machines.
I am.
And I don't. That seems to me a questionable thing to do.
Well, the point is that you need vocabulary terms which describe where you are in these phases.
Exactly.
And the thing is that whether you want to use poetic metaphors that are meaningful to humans, or whether you want to find really neutral clinical terms like satisfaction or increasing the value or disvalue of confidence, I don't really care. Because the point is that if you're talking to a lay audience, you might want to go ahead and analogize to human emotions, or you might want to use very clinical terms like is my thermostat satisfied that it has elevated my temperature in my house to the level, and it stops. Okay, so
you don't have to say did the resistance of the diode in my thermostat reach a point where it actually turned the machine, positive to doing something.
Right.
Well, that's what I say in my house, Harry.
Say again, Peter.
That's what I say in my house.
Okay, Mike Alexander has his hand up.
Exactly. Mike, you're up next. You're muted also, Mike.
Yeah, going back to the graph that you had, the so-called learning curve. The way
we'll get there.
Yeah. It isn't what you have there. Your labeling of the axis is not cumulative knowledge and beliefs. The cumulative knowledge would be the integral of what you've shown, because it increases. Even when you change your mind on something, you don't necessarily the cumulative knowledge that you're showing here essentially winds up with a derivative of zero, which is not good.
So, Mike, what you're saying is that when you have to unlearn something, it isn't necessarily a negative thing. It's saying unlearning is part of the knowledge process, and therefore you're constantly increasing your knowledge by knowing that a certain fact or theory or response is unproductive in whatever point you're trying to achieve.
Yeah, if you're talking about cumulative knowledge. Now, if you're talking about incremental learning, which is what I would say this is increment. This is, these are the increments. But because cumulative knowledge over the long term continues to increase and doesn't level off.
There's two things about unlearning. One is that you can have, this is really reliable knowledge. This is knowledge that you're relying on. And so you've discarded from the knowledge base the portions that used to be in the reliable knowledge base that you no longer rely on. Now you can also forget. Humans can forget. Databases can get corrupted or lost. So you can actually lose content of your knowledge base either through forgetting or other calamities, or intentionally throwing away some baloney that used to be in your knowledge base. So this is really the reliable knowledge that you've kept, as opposed to things that you've learned and thrown away. You can argue that it makes more sense to label knowledge as reliable and unreliable. Here I've basically made the vertical axis the reliable knowledge. So the slope is the rate at which you're gaining units of reliable knowledge or currently reliable knowledge. And the downturns is when you're throwing away parts is determined to be unreliable, that you don't want to keep as anything that you rely on to make predictions.
Barry, can you make the argument about artificial intelligence that it's basically humans driving it anyway, so therefore the machines, quote unquote, have to follow the human behavior pattern because in fact humans are driving it?
I guess it depends on whether it's a neural network that's learning in some sense autodidactically from examples, or whether humans are programming in the knowledge from human sources. The royal problem with neural networks, sorry, go ahead, Peter.
The human network has its basis in human knowledge. I mean, machines are only going to do what the people, what people tell it to do. Machines don't start with atoms and go from there, or maybe they do. I don't know.
Yeah. Well, if you're talking about giving a whole bunch of raw data to a neural network and say, figure out the coefficients of the neural network so that it agrees with the database. When the neural network says, I can now recognize a cat with 95% reliability, and you ask it, well, how do you know it's a cat? What are your criteria? And it says, well, it's just all in these coefficients and these linkages. So it doesn't really have any insight. It can't explain. What neural networks lack is the explanatory power of a theory. They say, well, I just know. It's like an intuition. I can recognize something. How do you know it? Well, because when I run it through this matrix of coefficients, it comes out yes or no. That doesn't really have an explanatory power. So you really want a theory that has explanatory, predictive, and diagnostic power. A lot of neural network machine learning lacks that. So
well, conversely, if I could throw it back on your head, how do you recognize a cat?
I don't know.
Exactly.
I'm willing to say I can recognize a cat. I know one when I see one, but I can't tell you the calculation I use because it's wired up in some kind of a neural network where I don't know the coefficients. I have an intuition. So yeah. What you do in science is you try to elevate an intuition to an express theory, hopefully a mathematical theory, but some kind of express theory where you can narrate and transfer the algorithm, the method, the I want to transfer the calculation to another entity. That's where the explanatory power of a real theory comes in. And that's why mathematical theories are so powerful, because that's a public language.
Understood.
Barry, I think I can answer some of Peter's question or your question, how you know something's a cat. And that is that if you've ever experienced, well, I never worked with a pathologist, but when you take pathology laboratory in medical school, first you see just a bunch of cells under a slide. And the pathologist begins to describe things that make a cell malignant. And at first you kind of get it, sort of get it. And then with repetitive learning, you learn to recognize those factors and can articulate them, which makes a cell benign or malignant. And then eventually you just look at it and you see it, oh, that's malignant. And you don't go through a checklist like a machine does, 1, 2, 3, 4, because the brain doesn't operate in that way. But it really does. It really is. It's finding all the elements and in background, and then saying these are the elements of a malignant cells that you just learned last Tuesday and that you didn't know last Monday.
Yeah.
And so the brain organizes information and somehow can pull it out of its little data fields and construct an answer why it's a cat or why it's a malignant cell. And if you watch the learning process and you watch students, which I did, how they at first have trouble retrieving that information, even though if you say it, they know it, but they have trouble retrieving it and putting in a clinical order. They learned it as a checklist, and now they have to put it in a clinical order. And you see the matrix being reordered as they become more clinically skilled. You see as the teacher, you see the brain working, like you're saying, to put things together. And you can see the steps yourself as a teacher, what the student is going through.
Exactly.
Even though mechanistically, nobody knows how we think.
Yeah, I was going to say, Jerry, just to be pragmatic about it, you don't know what's going on in people's mind when they do that. They may be going through that same checklist in that same order, but because of repetition, it has become so efficient that there's no way to measure the time, if you will, between the steps of cognition from the initial question to the final response.
Correct. And then when you're a specialist, it's so fast, it looks like you simply know it. But in fact, as in any field, when you're a specialist, you actually are going through that, but you go through it so fast, it looks like you memorized it and just know it, but you didn't. You figured it out every time.
Yeah. Bob Premack.
A couple of things. I would like to respond to Jerry. There is a sort of an imprinting-like process that happens in visual memory, where groups of neurons get organized and they form a sort of a template. So you're actually forming like the Gestalt therapists call it, a gestalt, a whole image.
Yeah.
And that's what becomes more and more detailed the more it is used.
That is true.
And that gets on to how people forget and how we remember. We remember the pathways that are used more and more often. They reinforce themselves biologically.
Correct. And that's why you have the phenomenon of color constancy, which is,
Yes.
if you look this, for those who aren't familiar with it, you can find it on the internet. And what they'll show you is like a picture of a strawberry in a shadow. And you say, they say, what color is it? And you say, well, it's actually red in the shadow. And then when you blow it up, it's pure gray. And you can see the red, but it's pure gray. And it's because your brain has superimposed what it already knows onto the image that a strawberry is red. And it tells you that it's red.
And to continue this bit about how we forget.
What you normally get.
It is normal. It is very normal for nerve pathways to be broken and discarded in the human brain. In fact, that's the reason why we have control of our emotions and why up until teenage years, we really pretty much don't. And
that's why you have to practice the piano.
It's also thought to be one reason why people with Asperger's disorder have poor emotional control, because the nerve pathways aren't broken. So that is actually part of learning. We unlearn certain pathways and we reinforce the ones we use and the ones that it's appropriate to use.
Carl?
Yeah, so I've been struggling some with this, the learning curve and where the inflection points are. Because I'm thinking of the saying attributed to Mark Twain that it's not what you don't know that hurts you, it's what you know for sure that isn't right. And there's the point where you discard incorrect knowledge. In other words, you thought you knew something, and then you realize that that's wrong. And so you're removing what I think of as negative knowledge. So isn't that aren't you increasing your knowledge at that point, as opposed to showing the downward curve?
You can argue it that way if you remember the mistakes and you keep them in your record book. If you forget your mistakes, you bury them, then basically they're vanished. So
Or you can make them again.
exactly. and
That's
people
what
do.
that's what we doctors do all the time.
You can see from this elevator that we're about a third of the way through. So depending on whether I've saturated people or not, we can keep on going because there's quite a bit more material, or it could be weighted till another time. But
Barry, let's keep on going. We
okay,
have about a half hour. And then
Yeah.
and since it's Zoom, people are flexible. If they have to leave, they will. And if they don't want to, they don't. We get to a convenient stopping point, and then we'll schedule phase 2.
okay. Now, remember I said, in addition to the phase plane diagram, which I showed, there's the phase space, which is 3-dimensional. And it's a little bit hard to show 3-dimensional, but if you've ever heard of the Excelsior Spiral, onward and upward, if I put affect on the left-right axis, learning and unlearning on the front to back, and cumulative knowledge vertical, then you get a helix. So that as you're going around and around the phase plane, you're ascending the cumulative knowledge axis, or the reliable knowledge axis, and you get something like a helix, but notice it's canted at a cockeyed angle, kind of like a squirrel going around a tree. So when you're building units of knowledge, you're kind of ascending on this back part, but then when you get to the point over here where you've got a disconnect between your reliable knowledge and your observation, you come back down the discard on this phase. So in 3 dimensions, the phase space is a helix, and it's well known as Excelsior Spiral. But the important thing is that it's at a kind of cockeyed angle.
Well, it's also converging. I mean, it's converging
Yes.
to a point.
Yes, it's converging to a point because the magnitude of the mistakes and the magnitude of the emotions is declining. Now, this is the optimal learning curve. You can also have pathological cases. Well, let me first show this one. This one is called the collapse of the roller coaster. This is somebody else's work. Same idea, except that they say if you're entering a phase of collapse, you have a crisis where your reliable knowledge isn't working, and you have a descent, and then you sort of stabilize, and then you do a partial restore, but you still have a crisis. And so a descending unlearning curve would be the collapse roller coaster. Same idea, but where you're starting off from a whole bunch of baloney and little by little discarding it piece by piece. I've got something very similar in a sidebar called pathological learning. This was the one that I first showed, the ideal learning curve, but you can have ones that go the wrong way, where you're building up cumulative baloney, and then you have to do a therapeutic recovery, come back down again. So you can use this model both for ideal positive learning, but also pathological learning, where you're building up crazy models and leading your country down the tubes. All right, so now let's move on to the next thing, which is the Barda cards. This is kind of an interesting application of it, because in our education, we don't just sit down and have a lecture with content. We often have cultural stories. So a lot of the education, especially historically, is through storycraft. And I want to sort of roll into how we can understand storycraft within the same context. So this is all about the Bardic arts and storycraft application of the same idea. Now, in a story, you have to have characters. So the question is, what the hell is a storybook character? How would you model a storybook character as some kind of a simplified human being? So when I first asked about how you define a character in a story, a friend of mine says, well, a character has to have beliefs, desires, and intentions. I said, only 3 things? That's kind of a shallow model. So over time, I kind of built up this layered model of an arbitrary storybook character, starting with the innermost fears and then other emotions besides fears. A typical storybook character has a backstory, and an actor really has to understand the backstory, even if it's not necessarily revealed to the audience. And then characters have issues, which are sort of unresolved elements of the backstory. They have beliefs, which can be reliable and unreliable. They can have erroneous beliefs. They have observable practices, derivative practices, which would make sense if the beliefs are sound, but if the beliefs are baloney, then the practices are not going to work. And then you have desires, which are in some sense the inverse of the fears. Dreads and desires are nominally inverse. And then you have your intentions. So this is one way to model a storybook character. And the inspiration for this came from Shrek. When Shrek meets the donkey, the donkey says, what's an ogre? And he says, we're like layers, like a parfait. And that was sort of the inspirations for this Schrecklich onion layer character model. So here's the same thing kind of spilled out a little bit. The innermost fears in a human or any character with a brain kind of work in the amygdala and hippocampus. The limbic system is the host of lots of emotions. You have your undisclosed backstory, which is the long-term memory, what you would disclose to a shrink or a therapist if you went into therapy. Then you have your burning issues, what are the unresolved issues in your backstory? Your sacred beliefs, which you can articulate, your derivative practices, this is the sort of your habitual behaviors, maybe in the cerebellum, kind of automatic. You have your heart's desires, which is sort of the dreams that are the reciprocal of your fears. And then in a drama, typically the antagonist comes on and avows an intention. This is sort of how you launch a drama. And then you have the drama, the foolish action reaction, the dreadful drama, which is your Schrecklich life story. And let's see if we can put a little bit of mathematics onto that too. So there's some narrative here, which I'm not going to spend a whole lot of time on. But after you sort of think about this, you get this very interesting little diagram in drama theory, which is kind of an analog to Nash's equilibrium in game theory. So here you have a storybook character. Say the protagonist is character A, and character A has an idiosyncratic set of characteristics, the defining characteristics. So character A does an initial gesture, an action, a remark, and then has to trigger a reaction from another character, say character D in a soap opera. So character D reacts to a gesture by A, mainly because they're disturbed by it. They have some negative reaction to it. They react, they're triggered, and then character B reacts to character D. And that reaction then triggers a third character, character F, to react. Character F reaction triggers C, C's response triggers E, and then this is the key thing, it has to close. Character E's reaction then has to close the loop, and you have to get this bouncing dialogue among the characters of your drama. And I took this theorem from Tom Clancy, who wrote a book called The Sum of All Fears, and from Shakespeare, who wrote Much Ado About Nothing. So the notion is the balance here that determines the continuity of a drama is really an expression of the net dynamic balance of all fears has to be nominally zero, so that you get this cyclical pattern. So you can go back to an arbitrary drama and sort of map out all the characters in a soap opera or drama, the protagonist, the antagonist. Typically, the protagonist and the main antagonist have opposite desires and fears. So the desire of the protagonist, as revealed through the intention, the stated intention, alarms the antagonist who gets up and tends to interfere and block it. And that's because for the antagonist, they've aroused the fears. So you get this sort of back and forth teeter-totter thing. And if you have more than two characters, then it becomes a soap opera. And so you can look at drama theory in terms of this mathematical model. And that's just one of the applications of this. And by the way, if you want to write a drama, so Socratic dialogues, dialogues, Plato's dialogues of Socrates, Galileo writes a dialogue to explain gravitational mechanics. If you want to write a dialogue, you might want to simply choose characters that enflesh all these things. So this leads you into mechanisms for insightful learning. In a lot of education, you get data, which is the answer to a question that you could have asked. What's the difference between data and information? Raw data is the answer to a question nobody's gotten around to asking. But if you ask the right question, then the data is the answer. So data and information are question and answer pairs. Some people say that data is just a collection of anecdotes, a collection of observations, and to some extent that's not unrealistic. But then if you have a whole bunch of question and answer pairs, you have to integrate it into a fabric of knowledge. This is like assembling a jigsaw puzzle. So I sort of think of knowledge as the assembled jigsaw puzzle, putting all the information. So if you ask a question and answer it, then the next obvious question comes up. And so you put adjacent question answer pairs together in the fabric of knowledge, and that gives you the insight. You see the big picture, and the insight is what we call wisdom. If you throw in a value system, personal value system or cultural value system, then you get wisdom. And what do you get out of wisdom? The ability to make stories, ability to make allegories and parables and fables and myths and educational stories, which may or may not be historically accurate, but they're educational. So story making kind of grows out of this. And what's the story? It's an anecdote. So there's a kind of a loop here. And in classical education, you're mainly working down here in the data, information, knowledge. And I'm pointing out, hey, let's add the top half of this loop. Let's learn to make stories that build on the knowledge base, walk you through the knowledge base with respect to cultural values and disvalues. And now you have this nice loop. And my feeling is that in terms of education, we need to spend more time crafting insightful stories. So this is the notion of insightful learning. And then the rest of this is kind of just a walkthrough. Here's a cute little depiction of data, information, knowledge, insight, wisdom, and theories. Could be conspiracy theory, but this is not a new idea. It's just one more way to sort of package the whole thing up into an application of emotions and learning. And that's the first part of it. I think I'll pause there because that's a lot to judge. I'll pause there to see if people want to say comments or questions on that.
Barry, I didn't see between knowledge and wisdom, there's something called judgment.
Yeah,
I didn't
and
see that in there.
Yeah, you can put judgment in here. It's really values and disvalues are really about judgment. The things are positive, becoming, good, worthwhile, and negative valence, disvalues, unbecoming, not to be promoted. So in some sense, judgment is really tied up in values and disvalues. Thumbs up, thumbs down, really. And that's how you decide whether to make a story that promotes positive behaviors or stories that are tragedies where things go haywire and everybody dies. So yeah, I would sort of add judgment in here. Any other comments? Or I have a little bit more we can at least tease or even go into. But the main thing is that there's a kind of a drama theory, like a game theory theorem that comes out of that.
I have a question for you.
Sure.
You brought back a memory. When I was a very young engineer, I went to my first design review out to the West Coast. And I forget the name of the company, but it was like MITRE here, the West Coast think tank for the, for DOD. Mm-hmm. And we were working on the Minuteman missile program on the console that controls the data. And in those days, they used paper tape. Well, somebody during the design review asked what happens with those little pieces of paper inside the machine.
The chits.
Nobody could answer the question. They were so deep in the technology, they weren't in real life. And the first thing that came to my mind, go get your car vacuum cleaner with a long snout and go and get it out, And I didn't say anything. My boss says I should have. But they were so incensed in their technical environment, they couldn't think of real life. Yeah. What would you classify that as? And these were all educated men, don't get me wrong.
Yeah. This is when you get from the concrete to the abstract. By the time you get to the very abstract analytical level, you leave the concrete behind. And the concrete are the examples, the everyday, real life exemplary experiences. So leaving the concrete behind is a downside of getting to be too abstract and too analytical.
And that's what happened there.
It happens all the time. Okay. So now I want to talk about one more thing. This is called multiple interlinked economies. And this is, again, inspired by some classical mathematics. In this case, Maxwell's equations. Maxwell said, you have something called electricity, electric field. You have something else called a magnetic field. And these are observed to be connected. And in particular, it took a long time to figure out how they're related. Perturbations in the electric field induce perturbations, well, they induce a magnetic field. And perturbations in the magnetic field can induce an electric field. So they have this kind of the sinusoidal interaction that Maxwell worked out. And I thought, I'm going to see if that same kind of influence applies into economies. So when you think of an economy, you think of the material economy, the exchange of goods and services for little pieces of green paper, and we call those chits. But traffic in the material economy, the flows and fluctuations in the material economy generate information, because people attend to what's happening, and these perturbations here become information. So activity here generates information and attention, and so we have the attention and information economies, which we can call bits and hits. And the flows and the fluctuations in the information attention economies, by the same process, induce new traffic in what I would call the entertainment and drama economies, because you want to start telling stories. You know, journalists want to tell stories, and other people want to tell. So you have the entertainment and drama economies, what I'll call fits and skits. And now here's the key thing. The traffic here corresponds to the activity here. Because why do we do drama and entertainment? Because we want to reveal emotions and also reveal the learning. So in a tragedy, like tragedy of Romeo and Juliet, the outcome is something, you know, unhappy. They die. And in a comedy, and Shakespeare wrote about as many comedies as tragedies, the characters identify their misconceptions, like Romeo and Juliet each believe the other's dead. So they have an erroneous belief. So dramas can work both ways, to reveal the dynamics of a tragedy, or to suggest the comic outcome, the point where people correct their misconceptions, have a big laugh about it, and go on, and all's well that ends well. So again, there's a connection between traffic here inducing traffic here. And interestingly enough, you can keep on going. Flows and fluctuations in the emotions and learning economy can then drive traffic in the spiritual economy, grits. Remember, way back up here, we had awe and inspiration. And this is, and also, you know, so you have all this encouragement, hope, spirit, awe, inspiration. So these are kind of elements that classically or culturally, we would talk about the spiritual economy. And so this is simply borrowing the mathematics of James Clerk Maxwell. Traffic in one economy induces traffic in the other. Flows and fluctuations induce flows and fluctuations, and it's like a slinky, okay? That is, traffic on one end of this connection will propagate through to the other end. So this is really kind of like the dynamics of the slinky. That activity here will propagate through these interlinked economies, and there's another way to think about material versus spiritual economy and all the other in-betweens. So that's just one more little thing that fell out of this thinking mathematically about this stuff. There's a connection to Socratic dialogues, because Socratic dialogues is one of the more classical methods of generating a synthetic dialogue between two or more characters to try to walk through a learning curve. And I've actually got a template for this. I'm not going to show it here, but it turns out that you can use this to generate synthetic Socratic dialogues according to a template that jives with all of this. And if you think of a questions and answers in a Socratic dialogue, there's really only 5 kinds of questions, no, 6 kinds of questions: who, what, where, when, why, and how. There's only like six words that begin questions: who, what, where, when, why, and how. And you can begin at the very concrete level, the most concrete level. You can ask 6 questions. And when you ask and answer 6 questions for a single concrete example, all 6 questions: who, what, where, when, why, and how, then you can escalate to the next slightly more abstract level, sort of a pattern. as opposed to a case, a pattern, a model. And you can ask 6 more questions at the next level up. And if you look at Maria Montessori's model of going from the most concrete to the most abstract, there's really about 6 levels of abstraction from the most concrete to the most abstract. So at each level, you can ask 6 questions for a total of 36 questions, working your way up. And all of these Socratic dialogue templates have 36 questions, 6 at each level of abstraction from the most concrete to the most abstract. And interestingly enough, that ties into a Kabbalistic legend that if you want to have a dialogue that continues all the way to the topmost level, you need 36 people, each one responsible for asking one of the 36 questions. And if any one of them fails to rise and ask their question at the proper moment, the whole thing comes to a grinding halt. So this legend, it's called the legend of the Lamed Vav, because Lamed Vav is just the Hebrew word for 36. And it turns out that the legend of the Lamed Vav from the Kabbalah ties into the Socratic dialogue. Who can ask the right question at the right moment in this 36 question, 6-stage level to keep the conversation going till you get all the way to the top of the most abstract level. And then the rest of it is just down here is the original peer-reviewed material from which this article is based. So that's really the whole story in an hour and 18 minutes. And I'll pause here for just people want to riff on this thing and digest it and comment on it and maybe suggest even where it should go from here.
I just want to say that the Socratic dialogues always drove me nuts because they always had such patsies asking the questions, you know, yes, Socrates, no, Socrates. Oh, you're so right, Socrates. I felt like if it just put a decent lawyer in there, Socrates would have gotten badly messed up very quickly.
Yeah, you can. I mean, that's what trolls do. On the internet, trolls are very good at asking a question which you wish they hadn't have asked. That's sort of that's the definition of troll. Someone who asks a question you wish they didn't ask because it kind of throws everything into a monkey wrench. And yes, I've done the Socratic method with people who knew how to derail it. They could just respond in a way that wasn't consistent with the concept of a Socratic dialogue. And yes, you can totally derail a learning process if somebody wants to throw in a wonky response to a Socratic dialogue. Okay.
Barry, those people are known to us old folks as gadflies.
Yes. Well,
and a gadfly is not a particular insect. It's any insect that flies around the horse and drives the horse crazy. That's a gadfly.
Socrates was called a gadfly. By the way, I just clicked on. So those questions, here's an example where I just sort of threw these templates from the most concrete down to the most abstract. And you can do this with lots of different premises. You can just fill in this template. And I wrote these, I think, I don't know, 35 years ago, but they all sort of
these look like questions from Lisa.
Yeah, exactly. If you wanted to go into a chat bot, these new AI chat bots, you might want to use a template like this to walk the chat bot from a very concrete beginning conversation up to, and see how far up the abstract scale you can go. And you might find some utility in that.
I want to create the chat box that asks the other chat box these questions.
Yeah.
Isn't so that like the Turing test?
A little bit. Yeah, because the current question you want to ask, I mean, I would do that too. I would ask a chatbot a question, not to prove, because I knew it was a chatbot, but just to see, how human-like or how synthetic the response was. And in particular, some of the chatbots would just tie themselves in knots. They would go into a gibberish mode, especially the one that Facebook put out. It was really easy to get to send it into tying itself up into knots.
Dick, you're on mute.
Yeah, thanks. I had a lot of comments, but there's only one major one I'd like to ask you about. I mean, I really enjoyed the presentation. I learned a lot, and it was great.
Thank you.
One thing, at least from my personal experience, that I wonder how you incorporate into your diagrams and into your charts, is that when I learn, I find that if I leave it alone for a while, all of a sudden I've learned something. In other words, I spend time thinking about something, maybe working with it, maybe doing mathematical equations and stuff like that, thinking so forth. And I come to an impasse or I run out of time. And then sometime later, and it could be after I sleep, but not necessarily. It could be anytime during the day. All of a sudden, it comes to me. In other words, the wisdom or the insight or whatever you want to call it is there. Oh, now I understand this. And there's no emotion that's going on during that time. Now you might think, well, the brain has gone through the emotions and maybe that's what's happening, but I don't think so. So I wonder how you incorporate that. People called it the eureka moment and stuff like that, but it's something that happens without emotion, at least as far as I'm concerned. What's your answer to my query here?
You can pick up a lot of information, little question answer pairs, and there's a very slow process. This is like assembling a jigsaw puzzle. It's very tedious and time consuming, and one piece of information by one piece, you're building a semantic network which connects the ones which are sort of neighboring question answer pairs. And that's a very slow, tedious process. You do a lot of it in your sleep. But once you have connected enough pieces of the jigsaw puzzle to where the big picture's coming out, there is at that point a kind of a sudden seeing of the big picture, which is the insight, the eureka moment. So there's a very slow, dull process, maybe half awake, half asleep, or while you're taking a walk or walking the dog or whatever.
But there's no emotion involved there.
Not much. It's very tedious. It's very mechanistic. But what happens is, as soon as you get the last piece of the jigsaw puzzle in place, and now for the first time you can see the gestalt, the big picture, that's a very sudden seeing. That's the insight, the seeing. And that, I mean, I don't know about you, but I've woken up in the middle of the night, when I finally got, a bunch of little pieces all fit together and I suddenly saw the story, then I would wake up and I would quickly write it all down or, do something so I wouldn't lose it. So the sudden emotion is when you finally have the big picture jump out at you. I see.
Yeah, I have to agree that the emotion is what I would call satisfaction. Now I know something I didn't know before. This is what it all means.
Yeah.
Now
I understand.
I would call it exaltation.
Yeah, it could be.
Choose your favorite word.
Another thing I have is about, well, we can go about the Socratic method because I went to law school and they talk about Socratic method there, but I won't go into that. The other thing is about neural networks. Most of you know by now that I hate when people in technology come up with these phrases, terms, and so forth, borrowing from previous uses of these words, and they come up with a new concept like artificial intelligence and so forth. And neural networks is another one. To me, the things that people are doing with AI and machine learning, those are not neural networks in the sense of being the neural networks of human brains or higher level organism brains. They have certain aspects of it, but to me, that's not what's really going on, because as we talked about just previously in this discussion, when you're forming a memory, what happens is that the brain, the human brain actually forms new networks as that's going on. It's not static.
Yep.
It's a dynamic process in which actual memories occur. And back probably 50, 100 years ago, a person came up with a concept called an engram. And an engram is a memory. And they didn't know where it was, but now we know that there are certain centers of the brain. Well, not centers, but areas where this goes on. So you're forming these things all the time. Whereas as far as I know, in machine learning, you're not forming any new neural networks. You've already laid them out, but they're not new. They're not being formed as we're gaining our knowledge, as we're gaining our memories.
Yeah, you're adjusting the coefficients of the linkages.
I don't think so. I don't think so. You're not adjusting the coefficients because you're actually forming new networks.
No, I was
You're
saying
actually
that,
forming them. You're biologically making them. In other words, there are new neurons that are being formed here and connecting.
New
what I meant
synapse,
is-
not
what I
new
meant is
neurons,
in the
new
artificial-
synapses.
In the artificial one, you're just adjusting the coefficients.
Yeah, yeah, right.
That's what I meant.
Yeah, right, yeah. No, I'm talking about the way that the people in machine learning talk about neural networks. I have a problem with that term, neural networks, and not neural networks.
Yeah.
In the sense of where that term comes from biology.
Yeah, they're nodal networks. You can call them nodes if you
Yeah,
like.
right. Node would be good. Yep.
Yeah.
Bob,
3 people have their hands up. 2 more people. You're muted, Bob.
Yes, I am not muted now. What was I on? I was on. Yeah. I think I was talking a little bit, I'm going to talk a little bit about that difference between biological learning and this type of artificial intelligence learning. Oh, about what happens in Dick's experience with the eureka moment.
Yeah.
What happens between when you step away and when you come back.
Yeah, right over here.
The human brain has been said we only use like 1/6 or 1/12 of it at any one time. That's not exactly true.
Yeah.
As modern computers have background processes, so does the brain. There are things always going on that are not conscious. And there's even unconscious emotional stuff going on you'd never be aware of. And so this rearranging and realigning and forming of new synapses and breaking away of ones that aren't useful, it's always going on. The reorganizing and organizing and even the evaluating. Even though you don't consciously reevaluate things, there are background processes which do this. And that may or may not partially explain what's going on there, even if you didn't go to sleep.
Mike Alexander.
Yeah, I'd like to suggest another piece of mathematics to you, Barry. When you're trying to get, say, from information to knowledge, and that's the use of the analogy of percolation theory.
Okay. Percolation theory. Okay.
Yeah, and percolation theory, you know, it's used, for example, as I knew it, for example, to understand how an electron can get from one end of a wire to another. Okay, if what you have is a lot of non-conducting media and some conducting media, it has to kind of jump from one to another until it can go from one conducting to another.
Yeah.
And until it finally gets to the end. And so the process is somewhat like a multivariate percolation.
That's in contrast to
Mike, were you
permeation.
just making a statement?
What?
Was Mike, were you asking a question or just making a statement?
Well, it's a combination of both. It was sort of like if you thought about something that was analogous to that, or you know, does it make sense to you?
I have to give that some thought because I'm not familiar with percolation theory. Here, I was thinking of the analogy of having a whole bunch of pieces of a jigsaw puzzle that are scattered, but theoretically connected, but you haven't got the connections. And then as you interlock them piece by piece, which is very tedious, you get a fabric of knowledge. I don't know if percolation theory describes that better than the jigsaw puzzle analogy. I've always thought the jigsaw puzzle analogy sort of makes sense of connecting loose pieces of information to a fabric of knowledge so that the big picture comes out and you can walk a path through the knowledge base, which is how you can make a story.
Barry, thanks. My brain is full again.
Thank you all for your kind attention.